constructed a simple DC motor, as you can see in the video. We've employed the pivotal parts of the motor to include a DC power source, an armature which consists of the coils that rotate, a magnetic field that's provided by the magnet, and these two paper clips that are acting as our carbon brushes, our conducting graphite brushes here. And we've used what we've done is the sides of the coil, we've shaven one side completely and the other side just the surface, because that forms our split ring commutator that reverses the current at every half vertical loop.
We began the experiment by setting up the DC power supply here. Make sure you turn this on. A common mistake every physics student does is forgets to turn that on and is thinking it's not working, but it's actually just this. Start by putting it on 6 volts, and obviously grab your alligator clips and put it onto a wooden plank. The wooden plank is a wooden base because wood does not conduct electricity. Yeah. And when that is ready, get a paper clip, twist it in such a style like this, if you can see it, and then put the magnet in between here. It can be put in any way. It can be put like that, like this. Most effective is this. And alligator clips on the side of the on the side of the paper clips.
We will be needing 2 connecting wires that end with alligator clips, preferably. A cylindrical surface onto which we can wrap our coil to form the armature. Tape to stabilize anything we need to in the motor. Scissors to cut off any wire and to shave any brazen enamel. Copper coils that are insulated with an enamel coating that we will be shaving off certain parts to ensure the functionality of the wire to the shape we need them to. Thumbtacks to stabilize them on our wooden base. 2 paper clips that will form the conducting brushes. A hammer to stabilize all on the wooden plank. A magnet that will form the magnetic field of our motor. And a wooden plank on the hull which will be stabilized. And we also have our DC power source which will bring this.
Skip the step in which we actually form this coil, but really it's really easy. You grab any base, any cylindrical solid, and you put it around here. So as you can see, my finger's inside it right now. And you wrap it around. The number of coils necessary range from 15 to 20, but I've seen some experiments that have 12 to 20 as well. Anyway, so we actually started with this. We put the magnet in here. As the one had shown us, we put the alligator clips, clip them onto the paper clip, which I showed you earlier, the arrangement. And 2 of those, stick them into the DC power supply, put it on 6. It is essential to maintain a somewhat low voltage of 6 in order to ensure safety and no short circuits. Anyway, are we going to start this? Okay. Ready? Give it a slight nudge because it itself does not have the strength to begin. No?